our next speaker, Cristobal Bordiu. Sorry if I mispronounced it badly. A telecommunication engineer and an astrophysicist working as a postdoc in INAF. And he's going to tell us everything, about where we're going in the next decade or so. Astronomical research in the next decade, trends, barriers, and needs in data access management, visualization, and analysis.
First of all, this is not going to be a technical talk. It's rather a sociological one, let's say, because I show the results or the outcomes of a survey about the way of working in the astrophysics community and current trends within the astrophysics community. So let's start by giving a little bit of context. Astronomy is changing, we know that, and it's changing very quickly. We have more and more data every day, and infrastructure is getting more and more complex. So we need to come up with new approaches to solve this and to deal with this. That's the reason why we are here this week. So if there is a word that somehow summarizes the situation, it could be data in big capital letters. So the situation is likely to become more complex in the next decade with the arrival of new telescopes like the LSST or SKA, which will produce very large datasets of several petabytes per year. This will represent a true technological and scientific challenge that will make us to transition towards a new way of working, changing the way we handle this data, we process this data and analyze this data. So this is where the NEANIAS project steps in. NEANIAS is a project, well, the name stands for Novel EOSC Services for Emerging Atmosphere, Underwater and Space Challenges. And it's an H2020 project with more than 20 partners from 9 countries that intends to become one of the facilitators of this transformation, this transition. And it does so by developing a series of thematic services, combining state-of-the-art tools and new software to address the needs, the specific needs throughout the astronomical data lifecycle. Also, we plan to deliver these services to the astrophysics community by integrating them into the European Open Science Cloud. And this way, we plan to build a collaborative, decentralized research ecosystem based on open science practices and promoting the FAIR principles, which are findability, accessibility, interoperability, and reproducibility. But there's a problem, and it's how can we make sure that our services respond to actual demands of the community? I mean, tackle the real world issues. Of course, we astronomers are familiar with the needs of the community, and we have some preconceptions, but it's always nice to put some numbers on this. So we asked ourselves, we can ask the community directly, so let's do a survey. And that's exactly what we did. We prepared a short questionnaire covering 4 major topics, which are open science, data access, data visualization, and data analysis. And for each of these topics, we prepared 3 sets of questions. Questions addressing current practices, like how often do you do whatever? So you have to rate from never to always in a 5-point scale. Questions addressing barriers or research issues. So we presented the participant with a list of potential issues, and they had to choose the most urgent one. And also questions addressing trends and expectations about the future, like how much do you agree with the following statements? So you have to rate with, again, with a 5-point scale. We send the survey via email to different research institutions, mainly from Europe, and also put a copy on a Facebook private group composed of professional astronomers that you have to get an invitation to access the group. And we are quite happy that we got a lot of responses. Actually, we got 329 participants, anonymous participants. So first, let's have a look at the demographics. About 1/3 of the participants were female and roughly 2/3 were male, with only 4% choosing the other option or skipping the question. And regarding expertise, most of the participants were senior scientists with more than 10 years of expertise. On the other side, the group of early career scientists were a bit underrepresented, accounting only for 12% of the participants. But the truly interesting thing is to see the participants per field of research. As you can see in this graph, most of the participants, about 60%, came from the galaxies and cosmology communities, and also from the stellar science community, followed closely by high energy astrophysics and also technology and instrumentation. On the other hand, we found that exoplanets and solar system communities were a little bit underrepresented, but we believe that the sample is large enough to be representative. So we know who answered the questionnaire, so let's dive into the results. The first topic was open science, and first we wanted to know the behavior of astrophysicists when it comes to sharing resources. And we can notice a very, very peculiar thing here. As you can see, the use of open source tools and the use of public data from archives seems to be widespread. But on the contrary, only 1/3 of the participants share their own code or their data products in public repositories. So this asymmetry is funny, because it could mean that we are more takers than givers. We need to change our mentality to promote open science. However, most of the participants acknowledge the value of open science in the future of astrophysics, because as you can see here, most of them agree that research will be done with open source tools, that processing and analysis will be done remotely, and also that collaborative and distributed approaches will be crucial for unlocking scientific discoveries. But maybe the most interesting outcome of this part of the survey is the concern about reproducibility. And this is a very trending topic, because I'm sure that you're all aware of this controversy some weeks ago about the potential detection of phosphine in the atmosphere of Venus, that some groups tried to reproduce and they failed to do so, so they conclude that the detection was not real. This is a cool example that highlights the importance of reproducibility as a key ingredient of the scientific method. So moving to the next, data access and management, the first thing we notice here is that the use of virtual observatory tools is still far from being the preferred option to access data. And this contrasts with the acknowledgement by the participants of the need of standards to ensure findability, accessibility, and interoperability of data. Another interesting finding here is that more than half of the participants work with datasets larger than 100 gigabytes, which somehow connects with what I mentioned in the introduction. But also it agrees with the generalized perception of data storage as one of the major issues for the future of astrophysics. But what about current issues? Well, at this point, findability and interoperability appear again as the most concerning issue. And this only indicates the need for standardization, which is crucial to ensure a proper use of data and resources in astrophysics. The next block addressed data visualization, trends and needs. And first, we wanted to know which kind of data astronomers have to visualize in their daily work. And many astronomers seem to have to visualize multidimensional datasets. On the other hand, the use of mosaics covering large regions of the sky is less common. And when speaking of new technologies, it's not clear if technologies like virtual reality or augmented reality are going to be useful for astrophysics, with more than half of the participants not being sure about their usefulness. However, it's clear that new data visualization techniques are needed to properly communicate and disseminate scientific results, both to the astrophysics community and also to the wide audience. But maybe the most impressive, outstanding outcome of this part of the survey is the generalized wide demand for visual analytic tools, which was the chosen option for 3 of every 4 participants. Just for the record, NEANIAS offers some pretty cool visual analytic tools, just in case you're interested to check them. But this is clearly the main need in terms of data visualization. And finally, the last section of the survey was about data analysis and machine learning. And here we can see some nice trends also. First, we noticed that many people works at least on a regular basis with data from multi-sky surveys. And also that those people gets involved very often in statistical studies about the properties of families of groups of objects. So in principle, this could mean, this could be regarded as the perfect ground for applying machine learning techniques. But as you can see on the third group of bars, the use of machine learning is not as extended as one might think. Only 20% of the participants use machine learning on a regular basis, and most of them use them never or just rarely. So this highlights an opportunity for us to keep working on these techniques and also to foster its implementation. The community, of course, acknowledges the potential of machine learning, and many of the participants agree that machine learning will be key in the future, and also that many scientific results will be achieved by machine learning only with little or no human intervention. But these techniques have their own problems and limitations, so many participants regard as necessary a detailed discussion about the potential biases and limitations of machine learning approaches in astrophysics. Finally, regarding to barriers, the most concerning ones are the source identification across matching between LSST survey catalogs, and also the availability of machine learning libraries and tools specifically designed for astrophysics. So these are the first results of the survey. Of course, there is a lot of work to be done because we still have to check the results disaggregated per specialty and per expertise. But for a quick look, we can assure that most of the trends hold. And this experience has been quite positive for us because it has provided us with very useful feedback to tailor our services for actual needs in the community. To summarize, we see that there is a moderate degree of adoption of open science practices within the community and an outstanding asymmetry in resource sharing. Also, there is a widespread concern about resource reproducibility. In terms of data access, it's clear that storage and standardization are critical factors for the future. We can see that there is a wide demand for visual analytic tools combining visualization and data analysis techniques in a single application. And finally, we notice this wide gap in the adoption of machine learning techniques, and we are entering in an epoch that will be dominated by LSST surveys and statistical studies about source populations. So there is room for growth. So basically, that's all from my side. If you're interested to learn more about NEANIAS and how can NEANIAS services tackle these problems, I invite you to visit poster P216 from my colleague Eva Shaka, and also don't forget following our social channels. If you have any questions, I would be pleased to answer them. Thank you very much.
Thank you very much for this. Thank you very much for this very insightful talk. I've got one question on Discord. The survey shows a need for visual analytics tools. Can you explain what is meant by a visual analytics tool?
Yeah, sure. It's basically a tool that combines visualization capabilities of ideally large multidimensional datasets with analysis capabilities that allow you to extract useful physical information from the images. A good example, for instance, would be CASA. You can analyze your data cubes here.
Okay, and I might ask a quick question. So this is a very useful survey. Would you see any use to, running something like this once every X years, similarly to, Stack Overflow runs the, developer survey pretty much every year, and that's used quite, broadly to shape pretty much the landscape of, we see which languages go up, which languages go down. The developers quite often make decisions based on the results on this survey. Of course, the scope is much greater. They've got like tens of thousands of developers answering every year. Do you think, repeating a survey like that you've performed every X years, would help us to see where we're going and what languages we should invest into, what methodologies we should invest into?
Sure. Actually, we don't plan to repeat this survey, but we have in mind to conduct a second survey more focused on machine learning techniques and programming languages. So I've heard that the Discord will be kept open for some time. So maybe it's a good place to disseminate the survey.
Yep. Okay, perfect. Thank you very much again.